Welcome to our video tutorial on setting up a Java cryptography project. Are you ready to dive deep into the world of secure programming? Today, we'll walk through each step required to successfully establish your own cryptography project using Java, along with practical code examples. First, let's start with a brief introduction to cryptography. Cryptography is a method of protecting information by transforming it into a secure format. This transformation ensures that only authorized users can access or interpret the data. In Java, we can leverage the Java Cryptography Architecture, JCA, to implement various cryptography algorithms and protocols. To begin, we need to set up our development environment. Ensure you have the Java Development Kit, JDK, installed, preferably JDK 11 or later. If you haven't installed it, head to the official Oracle website and download the latest version. Now that your JDK is installed, let's set up our Integrated Development Environment, IDE. For this tutorial, I recommend using IntelliJ IDEA or Eclipse. Both IDEs provide robust support for Java development and are widely used in the industry. Download and install your preferred IDE from their respective websites. Once your IDE is set up, create a new Java project. Let's name our project Java Cryptography Demo. Open your IDE and follow these steps. For IntelliJ IDEA, select New Project from the welcome screen, choose Java, and click Next. Name your project Java Cryptography Demo, and specify the SDK as your installed JDK. For Eclipse users, select File, New, Java Project, enter Java Cryptography Demo as the project name, and click Finish. Now that we have our project set up, let's start coding. The first thing we'll do is create a simple encryption and decryption application using AES, Advanced Encryption Standard. Create a new Java class in your project directory named EncryptionUtil. This class will contain methods for encrypting and decrypting strings. Here's how you can structure EncryptionUtil. In this code, we import necessary classes from the javax.crypto package. We create a method named encrypt which takes a string and a secret key as inputs, performs AES encryption, and returns the encrypted data as a byte array. We also have a decrypt method that reverses the process. Next, let's create a method to generate a secret key for AES encryption. Add the following method to EncryptionUtil. The generateKey method uses the keyGenerator class to create a new AES key with a size of 128 bits. You can change the size to 192 or 256 bits for more security, provided your Java environment supports it. Now, let's test our encryption and decryption methods. Create a new class called main in the same package and write the following code to test everything we've implemented so far. In the main class, we generate a secret key and provide a string original data to encrypt. After encryption, we print the encrypted data, followed by decrypting it back to the original string and displaying the result. Run the main class, and you should see the output similar to this. The encrypted data may look like a random series of bytes, while the decrypted data should display the original string. Great! We've successfully implemented basic encryption and decryption using AES in Java, but there's more to explore. Next, let's talk about hashing, which is another crucial aspect of cryptography. Hashing is a one-way function that transforms data into a fixed-length string, making it irreversible. For our next example, we will implement hashing using SHA-256. Update your EncryptionUtil class by adding a new method that will hash a string using SHA-256. This hash method creates an instance of message digest for SHA-256. It processes the input data and converts the resulting byte array into a hexadecimal representation. Now, let's test our hashing function. Update your main class to include a demonstration of this new hashing feature. Run your application again, and you should see a hashed representation of your password printed to the console. Hashing is an essential aspect of securely storing passwords and verifying data integrity. Now that we have covered encryption, decryption, and hashing, here's an important point to remember. Never hard-code your encryption keys or sensitive information in production software. Instead, consider using a secure vault or environment variables to manage sensitive data securely. Finally, let's discuss securing our application further by implementing proper exception handling. In production code, You should examine potential exceptions thrown during cryptographic operations and handle them appropriately. Using these catch blocks, we can provide meaningful error messages and improve the robustness of our application. Additionally, you might consider logging these errors for better tracking and debugging. As we wrap up our Java cryptography project setup, let's summarize what we've covered today. We established a Java project, created an encryption util class for AES encryption, decryption, and SHA-256 hashing, and discussed key management best practices. Remember, cryptography is a highly specialized field, and it's critical to stay updated with the latest security practices and standards. Always perform regular code reviews and security audits to ensure the integrity of your application. Thank you for joining me on this journey into Java cryptography. If you found this video helpful, please give it a thumbs up and subscribe to stay updated with more programming tutorials. Feel free to ask questions or share your thoughts in the comments below.